are given the diagram of carbon tetrachloride and asked to define electronegativity. Now every element has an electronegativity value which we can find on the periodic table. Electronegativity is the tendency of an atom to attract a pair of electrons towards itself. Then we are asked to draw the Lewis structure of the above molecule, our carbon tetrachloride, and indicate the octet rule for each atom with circles. And remember, the octet rule says that every element would like to be surrounded by 8 electrons, and that's because it will then have an outer energy level filled with electrons. We are asked to draw the Lewis structure for the above molecule, the carbon tetrachloride, and indicate the octet rule for each atom with circles. Now every element would like to be surrounded by 8 electrons because then it has a full outer energy level. So that's what the octet rule is telling us. So if I'm to draw the Lewis diagram here, I'll see that carbon is in group 4 on the periodic table. So that tells me it has 4 valence electrons which can take part in bonding, but specifically each of those electrons are by themselves, so every one of them can form a bond. Then chlorine, being in group 7, has 7 valence electrons and it has a valency of 1. So only one of the 7 electrons are able to form a bond with the carbon. So our chlorine, 1, 2, 3, 4, 5, 6, and its 7th one there forming a bond with carbon's 1 electron. Another chlorine here, 1, 2, 3, 4, 5, 6, and its 7th one. Let's just make that more visible. And then our chlorine here, 1, 2, 3, 4, 5, 6, 7th one, and the last one, 1, 2, 3, 4, 5, 6, 7. And now to indicate that each one of them are surrounded by 8 electrons, I see that this chlorine has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. The next chlorine, 8. 8 around that chlorine, 8 around that chlorine, and if I also circle the carbon, 2, 4, 6, 8. So yeah, you can see carbon 1, 2, 3, 4, 5, 6, 7, and 8. So all following the octet rule. Consider the following statement. Carbon tetrachloride is a polar molecule. Do you agree or disagree with the statement and justify your answer? Remember, for a molecule to be polar, it needs to have polar bonds. Now, polar bonds we find when the bonds have a difference in electronegativity. So if I look on the periodic table, I'll see that carbon has a certain electronegativity, chlorine has a certain electronegativity. There will be a difference in the electronegativities, and if I find the difference, I'll see that carbon has a slight positive charge and chlorine has a slight negative charge, and that will be the same between every chlorine and carbon, between that, and between that. So it definitely has polar bonds, but for the molecule to be polar, it needs to have a shape which is not symmetrical. However, the shape that our carbon tetrachloride forms here is a tetrahedral shape, and since the tetrahedral shape is symmetrical, the effect of each polar bond cancels each other out, making the entire molecule non-polar. So our carbon tetrachloride has polar bonds, but because it's a symmetrical molecule, there's an equal distribution of charge, and so the entire molecule is non-polar. So I definitely disagree with the statement.